Thank you, Manish, for introducing us, and thanks, Zino, for giving us an opportunity to present in front of the industry experts. So, this is a picture of De Salbe. It's a marathon which is organized every year in Sahara Desert. As part of this marathon, athletes have to prepare a lot. It's a 7-day marathon, by the way, and yeah, the distance is 160 miles, approximately around 257 kilometers. The participants and the athletes have a limit to carry a crub weight of around uh, 13 kgs, and usually average weight a particular athlete carries is in between 6.5 to 8 kgs. This weight usually differs. It's in between 6.5 to 8 kgs based on the athlete's physique, body structure, his own weight, height, and various factors. What to learn out of this is that to complete this longer journey, they actually have to do meticulous amount of planning. They have to realize various factors, their own physics factors. They have to do retrospection of this and imagine the amount of optimization that they will require to complete this journey. It's not just about winning over here. Just to finish this journey, a lot of efforts goes into all of this. With this, you be able to resemble with our fast journey. Now, when we begin, how we should be adding resources till the day when we are excelling with customers, how much amount of investments which we will have to do. This particular aspect, hook on to this particular aspect and this particular example, and try to understand various parameters which we actually consider in SaaS engineering while we are building the SaaS products. As part of today's agenda, we will actually go through the journey of SaaS product development and various factors that we usually consider, which influences performance engineering and helps us attain our performance goals. In these initial phases, I will be covering the business, architectural and engineering aspects that needs to be considered. Those are some visions which usually architects do go with in the SDLC lifecycle. I will be accompanying Devendra here. Later, Devendra will actually go through the various practical aspects, how to execute this on the shop floor to meet our expectations of performance engineering, and also to meet the how we can lean the costs on the shop floor. As part of the journey, it's very important to determine which parameters you are going to target at what phase. In the earlier phase of a SaaS product development, usually you do have very lean teams, and the kind of architecture that you choose, you may end up preferring a monolith on top of a microservice oriented architecture based on the various factors which influence managing the system. So when you begin, usually you pay attention to low infra costs. You pay more attention to SLAs, uptime, and in this particular journey, as you grow, right? First, you begin with reliability. Gradually, you concentrate on very few factors of performance optimization. Usually, it's done manually. When as a business you don't start with millions of users, right? You usually plan for thousands of users, then you grow towards supporting millions of users. Yeah. The second thing is that as you grow, as the new team members add on, you will see that there are very general challenges you will face. You need to book the time slot for your performance engineering setups. You will see that the costs in your production obviously starts growing because you are adding new functionalities, and there is a lot of over provisioned scenarios you start seeing into production setups as well as in the performance engineering setup. So from that particular perspective, a lot of efforts start going into booking the slots, waiting for those slots, executing. Many a times those tests fail. Again, you have to re-execute, and there are delays which start getting introduced. This is the time when you, as a organization, will have to start thinking, how can I shift left the approach of performance engineering? How can I automate it further so that my operational excellence can be achieved? As the organization grows, right, to support growth, we have to do some kind of capacity planning, because we usually can predict, but that prediction is not accurate. So you usually have to provision your production environments with 150% of the capacity, so that we can meet the linear growth of an organization. In this particular aspects, if the organization works on a thematic basis, there will be events which you may have to support. For those events, you will have to upscale and downscale the systems. How to upscale, how to downscale, all of this primarily depends upon the nature of the business. Furthermore, as the business grows, you will see that you will have to expand to different regions. Now is the time where you will start thinking about higher SLAs, 5-9 systems, 4-9 systems. You will have to take data-driven decisions. You cannot provision the same hardware that you have provisioned on your highly used region into your least region. So how do you decide what is the appropriate amount of provisioning that you do in production as well as in performance engineering? Do I actually test for average amount of utilization? Do I have to test for max amount of utilization? These are the data driven focus that you will have to look into. Modernization of this industry has played a very big role in the overall investments that we do into infrastructures that you deploy in production, as well as the infrastructure that you deploy in performance. When you go with a cloud-based system, the considerations are different. When you go with a system which has been deployed in-house or in the data centers, there are different considerations that you make. Because when it comes to the cloud-based systems, it's more about pay-as-you-grow model. Whereas when you are in the data center, it's a pre-provisioned hardware which you have already invested into. So the considerations of performance engineering also varies based on those factors. Uh, as you grow, right, performance engineering to attain peak performance with lean costs, it's not a one-day job. It's a continuous cost optimization process, because you keep on building new features, you keep on deploying new features. Your customer base keeps on growing. The trend of the utilization keeps on changing, and that's where there has to be a good architecture in place, which actually help you continuously improve. The final stage, which usually ideally every organization envisions, is how can I put my performance engineering into my pipelines, so that I can find those issues earlier. And if there are bigger issues, how can I find those before it goes to production? So these are in a usual journey of a SaaS, you will see that there are various parameters which you have to meticulously plan. You have to consider. You have to start with limited investments in the beginning, linearly grow rather than exponentially grow in your costs. Um, this all factors matter a lot from the cost optimization perspective. What are the various things from the engineering point of view which actually contribute to the costs, both in production as well as in performance? When it comes to the definition of from the technical point of view, the amount of data that you manage, we first have to determine, are we a performance centric product where we do have a lot of algorithms to be evaluated, or we are a data centric organization where we have to store a large amount of data. and retrieved, stored and retrieved. So from that particular perspective, your infrastructure provisioning and your data management is going to play a bigger role. The way you manage that data is very important, not only in production, but in your CI/CD environment or in your performance engineering environment. If you are handling peta and petabytes of data in production, that does not mean that you have to test for peta and petabytes of data in performance. You have to make a very articulated choices and very precise choices of architecture. Can I actually go towards a cell-based architecture where I have to test a cell rather than testing for petabytes of data? Taking as an example, if my production data is like 15 petabytes and my cell size is 1 petabytes, it's not a bad choice, by the way. Cell-based architecture is not a bad choice in this case. The reason, because what you need to test is 1 petabytes of data size, which is like 15 times less cost in production. And still you can guarantee the same lean peak performance for that particular cell. That kind of a choice needs to be taken care of when it comes to data management. When it comes to compute management, uh, period of execution plays a very big role. Whether I go with the provisioned infrastructure, whether I go with a serverless infrastructure, depends on the execution pattern that has been observed. If it is a scheduled execution pattern once a day, go for a serverless infrastructure. Cost will be lean. Uh, Performance engineering costs will also be very lean in those cases, because you have to only test performance of one single particular execution of a Lambda rather than testing the deployment. When you actually go and test a scale performance, you may have to go and test for a peak performance on a serverless. But when you have gone with the cell-based architecture, you just have to test with the fleet of microservices which have been deployed for a cell. In this particular manner, you don't always have to think about testing full blown. We will in the next slides we will see how we can build a performance pyramid to bring down those costs. Going further, tools and licensing plays a big role into performance engineering. You can go with open source tools because they help give you some API capabilities. JMeter is there, Gatling is there. At least from the organization perspective, we will see that organization push to use a single tool. I am of a different opinion. To keep costs lean, you may have to adopt a tool as per its capabilities. When it comes to performance automation, you need APIs on your performance engineering tools, and there are good open source tools which support APIs. You should go with those because those will keep your costs low. And when it goes to stress testing and at the peak of the pyramid, at the tip of the pyramid, when you are doing a full blown stress test or a load test, for that you can go for a license tool where you need to generate a lot of reports and analyze a lot of reports manually. Tooling will play a very big role in your expenditures of performance engineering. When it comes to decisioning from the product and the engineering point of view, what kind of a strategy that you are going to determine for your consumption growth or customer growth in the real world simulation is what you should target. Going 10x on day one is not helpful because you will end up spending more in your performance and more in your production. So product plays a very big role. Usually we observe that product goes with saying that give me the best of the best and support best of the best, test for best of the best, and make that product available to me in the given timelines. In this particular aspect, right, the overall, it's a triangle: cost, compute, expense, performance, fits into a triangle. So you don't get all of this at a go. You have to compromise on one, and where you get the benefits of others in the initial times. So product plays a very big role. Product has to draw those models which we need to support, and that's where the real world traffic simulation comes into picture. Communication overheads will increase in your journey, and you should emphasize upon that gradually as you go to reduce down the communication overhead, how you can utilize automations. uh, Third thing is in the journey of SaaS, right? And for the legacy system, you usually move from a monolith to microservices, or you will move from cluster oriented architecture to a microservice oriented architecture. A domain driven development decisions will play a big role. Cross region, from the product point of view, going into all regions, you need to decide that sweet point. Begin with a single region, then go to other regions. As a business point, this is the decision when you are building new products, plays a big role. Test costs, performance engineering costs, and your production deployment costs vary a lot. Whether I want to go with multi-cloud will also play a big role, because your engineering costs as well as performance engineering costs vary based on that. It's always advisable to start with one cloud system, stick to that for initial years, and gradually move to the multi-cloud support to lease the benefits of optimal costs as per services provided. Debugging and optimization is one thing where engineers put on things or requirements saying that all my performance engineering setup should be up and live for 24 by 7. That is not appropriate. You may have to revisit those decisions. How can you scale up and scale down your performance engineering and production systems based on scripts is what we should be looking into. These are all the cost factors which play a big role in production and performance engineering, infrastructure as well as execution. We should be paying more attention to. I will take an example of airline industry. Uh, uh, Boeing 747 is a big aeroplane. It has a huge capacity, long distance plane. Whereas Airbus or Boeing 342 or Airbus 380 is a plane which actually is a small capacity plane. Airline industry is a industry where you have to streamline your fleets. You cannot run a Boeing 747 on a shorter journey or during off seasons, because the costs will be higher. But you cannot actually run Airbus 380 for a longer journey. Your stops will be more, and you cannot even deploy Airbus Boeing 747 during the event times, right? So they have to have a sweet balance in between the types of the planes that they have. So to scale and tune during the workloads, and from the cost efficiency perspective, provisioning plays a very big role. You need to know your growth. You need to know your execution hours. You need to know in your systems where you can vertically scale. What kind of a plane you need to use? You need to use a bigger plane, a bigger system, or you can horizontally scale. You can deploy more Airbus 380 to meet the need of an hour. You also need to determine what time of the day that scale is been that pattern has been observed, day, weekly, monthly. You will have to determine that. Certification and the architectural choices that you make in the software industry, just the way that you the choices of the plane that you make in the airline industry, you will have to certify the architecture also and make the choices when you make that pick. A right sized infrastructure instance, a right sized infrastructure is going to help you reduce down the costs. The time to catch issues, performance issues, or your test issues later in the life cycle is going to add on a lot of cost and quality issues. So shifting left is going to be a big role that it is going to play a big role in your software development life cycle. There are various performance engineering factors that need to be considered. Performance engineering, mind well, performance engineering burns a big hole if not done in the right manner. So we are going to cover the business decisions which actually impact the expenditure for our performance and production deployments. Architectural decisions, how do they matter? Process and planning from the engineering point of view, and the discipline that we inculcate. All of these factor a lot into the expenses of performance engineering. Let's start with the business decision. We almost covered few in the first slide, so I'm going to breeze through this. Cloud strategy. Going multi-cloud is not a good choice when you are starting or you need to evaluate new product ideas. Stick to a single provider, crack a deal with them, negotiate with them. In fact, many cloud providers for the initial times have free tier. Make maximum use of that free tier. So the cloud strategy plays a big role from the business point of view. Also, or emphasize more upon the functional part of it rather than the non-functional part of when it comes to cloud strategy. Management and maintenance of CI/CD pipelines, deployments, testing is very simple when you go with a single cloud. As you grow, when the customer demands for multi-cloud, when you grow to the enterprise side, you are looking for enterprise customers who want to stick to a very specific cloud partner. That's the time when you should start thinking about going multi-cloud. Uh, from the target market audience perspective, when it comes to cloud, there are regions which are expensive. If you go to Asia Pacific regions, those are expensive regions. When you go to North American regions like Envir or Oregon, and Envir is the cheapest region. So take a decision in the earlier stages. If your SLAs are lower, your uptime requirements while you are experimenting are lower, go with the Envir region. The even the cloud provider guarantees less SLAs for those region, and you will end up saving more. Gradually, when you have tiers defined for your customers, define the tiers within the regions also. These are my tier 1, tier 2, tier 3 customers. Accordingly, provision those in appropriate cloud environment and the cloud region. So with that, you will be able to control costs in production. If when you go with a single region, initially your performance costs also varies. You don't have to do cross region testing because mind well, as a cloud provider, you don't get the same free tier across multiple regions. The amount of free tier you have as per region varies. A burst concurrency for a serverless infra in NA1 or Oregon region will be 1,000, whereas a burst concurrency in other regions like Canada will be 50 or 100. So it varies. Accordingly, you will have to take those decisions and see if you can stick to a single region. Anticipate growth. Testing for millions of users when you begin the business with 10x scale is obviously going to add up on cost. That investment that you do into testing or infrastructure can be used for your marketing and sales purposes. So performance can be guaranteed gradually. Define your 2x, 3x provisioning or growth, and accordingly provision. If need basis, make a choice of having better monitoring on your capacity management, which will invest into those direction of engineering rather than provisioning higher in the production and performance. Define right SLAs. Not everything can be finance when it comes to business. The reason because finance comes with a cost. You have to replicate the infrastructure across regions. You have to replicate information or data across different types of data stores from the uptime perspective. You have to do caching, which is expensive than your physical storage. So to meet the uptime of finance, your architectural choices are determined by your business decision of SLA. So make a choice tier the service appropriately to keep the cost lean. It's not just the responsibility of architecture or engineering which puts on the load into production, how much we provision. It's a business decision also, which plays a major role into provisioning. Time to market, SLA, anticipated growth, targeted market, as well as cloud strategy will determine your time to market to meet your time to market goals. The more baggage you carry, time to market will be greater. So emphasize on the other factors where you will have to trade off, make a trade off. The amount of money you put in, and the amount of timelines that you have, the timelines that you have slated. Uh, all of this is inversely directly proportional in some senses. So make right choices to save upon costs in the earlier stages and scale linearly rather than exponentially, or don't provision exponentially and have a flat investments for next 5 years. That also you will end up burning a lot. Architectural choices play a very big role here. When you start as a startup, right, you have a stipulated amount of fund. You have very lean teams, smaller teams. So architectural choice is going to play a big role. Given a choice with all the factors, even if I'm building a SaaS system, SOA system, where I have to separate the responsibilities of services. I will still go with monolith. I will have less services. I will begin with monolith, having a. It doesn't mean that my presentation layer has to be bundled inside a monolith. You can have a thin client instead of a thick client, but you can merge the domains. You can live with platform and your application services together, bundled together, because it is very easy to test those systems. It is very easy to deploy those systems. It is very easy to maintain those systems in the earlier stages. As you start hitting the scale, or you are linearly growing, you will come to a stage where you will need vertical scaling. That's the time when you as an architect determine, yeah, this is the point to break this system. You have to enter into some anti patterns during that time. Like you will have to enter into an anti pattern which is a shared resource pattern from the database's perspective, and gradually you separate out the database. So those architecture patterns are going to play a big role. When you are a monolith, you make maximum use of your resources. The drawback is you have to vertically scale the systems in many cases to meet the need. Gradually, as your customer base grows, as your requirement to scale grows, split the microservices. Make the technology choice which is required for microservices. Technology choice doesn't determine your architectural pattern. So use the technology that is being used for microservices, but you can combine the domain together to build monolith. Later on, it will be easier for you to split it and horizontally scale it as your team sizes grow. When you have multiple agile teams with a defined responsibility to which microservice they own, split it into microservices. Uh, Based on the business behavior, whether it is going to be linear throughout the day. I want to deploy a service which is processing data, go for microservice oriented architecture or a provisioned architecture. If it is a event driven thing, you are generating reports for billing and all those purposes, go for serverless architecture. Your cost will be lean there. So architectural choices also determine your performance and the production investments there. Let's step into engineering. The journey of engineering has been it's not been flat. A QA engineer or a engineer on the team initially started as a developer. Later on, the expectations have grown from our engineers. As we have gone to data centers, we started building web systems, from desktop systems, where from web systems we started building, deploying data centers. From data centers we moved to cloud. The responsibility has changed. There is a high awareness of the responsibilities which are required from the performance engineer, from the QA perspective, which are very centered to a data center. But when it comes to a cloud, uh, many of the organizations aspire a lot of things, and there is a very rare awareness of things which are required, or which we expect from our QA engineers. A ratio of any software engineering team, right, is usually 80-20, is what I have observed. 20% QA members, 80% developers. In this particular 80-20 ratio, what I am showing here is the expectations that we expect from our QA engineers today. Is it fair to expect all of this to be done manually? Is it fair to expect all of these things from our QA engineers? Is what we need to decide. How can I facilitate my quality assurance team with automations? Is what you will have to look into. How can I automate each block that you see here? I'm not going to go through the details of it. Whenever this presentation or the video will be shared, you will be able to go through the individual aspects. But to emphasize upon, while I'm on this slide, is go and retrospect what is the baggage that your QA engineer is carrying in his journey. Will we be able to even complete that journey with this baggage? Connect with the picture or the example that we took. It's a long journey. With all of this baggage, you will not be able to run through the journey, or else you will end up spending a lot on provisioning. Your systems will be up for 24/7. Your resources will be wasted for a lot. You will be carrying a lot of baggage along with that. So, as you see, we covered more. Your QA engineers start becoming a single point of failure, start becoming bottlenecks. So automation is where you will have to go to. When you automate most of the aspects that you saw on the earlier screen, time to market will improve. Reactive, you will go from a reactive solutioning to a proactive solutioning. More of a system will inform you about gaps rather than you figuring out by going through the reports what has gone wrong. We will understand from Devendra how the reports usually help. As with growth, growing backlog, think about automations. Uh, as you stay manual and as you grow, degradation of quality keeps on happening. So you have to more emphasize upon automation if you want to avoid degradation of your quality. With this, you in the longer journey, focus upon automating your benchmarking process, focus upon automating your performance process, capacity management. If you have alerts and alarms and reports built on your production consumption, your capacity can be well determined and your provision can be well determined based on the capacity. So invest into those automations more while you are growing and you want to support growth. It's not at the start that you do this. In the support growth phase, you will start doing this. And when you go to multi-region or in the support growth phase, when your SLAs start getting higher, invest into automating chaos in under your pipelines. This is the engineering aspect of it, where you will have to invest into addressing the ownership part of it. Your team composition, when it comes to the management perspective, the size of the team is going to matter. The number of teams and the investment, that is going to matter. Process automation, when to begin it, where to invest into, that is going to matter. Which kind of a architectural choice that you make, that is going to matter as an architect. The various architect choices that we saw. Shift left gradually as you grow your business. Keep 10 to 15% dedicated technical tech depth and scalability aspect bandwidth. From the product point of view, Product usually will emphasize into investing 100% into functional while we begin. Nothing wrong in that. But as product, there may be many product participants on this particular presentation, right? For them, this is really important. A 80-20 rule of product and tech debt based on your kind of domain. If you are a technology centric domain, that even might become 60-40 or 70-30. But investment into scalability in the earlier stages of software development lifecycle, when you have gone to market, when your MVP is out, start investing at least 20% into all of the aspects of automation monitoring that we discussed. Uh, Shift left. If you don't shift left on performance engineering, it's going to be you are going to spend into provisioning. You are people will have to take slots to run those reports. They will have no if there are manual mistakes, they will have no chances to correct those, because other you will have a queue, right, to attend for the slots, and 24 by 7 provisioning will require. So you can save costs as well as you can increase your time to market if as business you support them with 20-80 or 30-70 rule. Finally, these are few of the things that actually matter. Monitor your production usage. Focus upon benchmarking. What we have observed in performance engineering is that performance engineering is like, I have to support 1 million users, I will test with 1 million users. Ideally, performance engineering also has to go away from that particular thought process. Load testing automation usually happens in the later stage of the software development lifecycle with a full-blown test after integration. So that is pretty late for any kind of a discovery when degradation happens. That adds upon your cost in the development lifecycle, by the way. So see how you can actually shift left there. From the chaos automation perspective, you have to think about, because your architecture choice that you made, whether it is a monolith architecture, from the resiliency perspective, if any my dependent system goes down, what is the impact on my system performance is going to play a very big role. Whether my system degrades, whether my system rate limits in circuit breaks in case of failures, it doesn't pass on that particular failure to my dependent systems. If something is going wrong, it allows dependent systems to stabilize by using circuit breakers. I am curbing my incoming load, because if there is no exponential backoff implemented by my clients, that load is going to keep on retry. People or systems are going to keep retrying. Your systems cannot stabilize. So, have you made right resiliency choices there? Have you put in rate limiting? Are you having containerization or containerization of the problem? Are you isolating the problem? Do you have timeouts on your request? Do you have timeouts under your queries? All of this is going to matter. So chaos automation and chaos engineering from the performance point of view is very important to determine and certify your architecture. When you commit for 5-9 SLAs, these choices matter a lot. Your downtime cannot be more than 3 to 4 seconds. Practically, humanly, with the manual aspects, it is not possible to attend 5-9 architecture. So chaos engineering is going to play a big role there. Uh, Ultimately, what we have observed in our experience, we also started cylindrical. We used to execute our tests in all tests in all environment. That's when we realized that we need a test pyramid to be followed. Gradually down the line, as our customer, we started with like 0 customers with a very lean business model with 1,000 users in the beginning. As we grew in the business, we went from 1,000 to 10,000 users, 10,000 to lakh users, and we are supporting millions of users right now for our SaaS system. We followed the same, we categorized our business need accordingly. So we were able to keep our team sizes and our infrastructure costs lean. In this journey, what we understood is that we ended up spending a lot on performance engineering, because we actually never shift left in the earlier stages, and we in fact have an opportunity to shift left. We used to do stressed and load tests on a full blown model. When we are in a SaaS based model, we realized it late that okay, in some architecture, a choice of cell based architecture will help us extrapolate the costs and have performance engineering costs low. These are a few things which are very important to consider. We invested into the benchmarking side. We run the test at with a single instance every sprint. It's an automated system that does it. We invested into that for a release. Now, every Saturday, a report is being shared with engineers and with the summary of it. If there is a degradation or not, because we have defined benchmarks there, and the report is been analyzed programmatically. It tells whether the degradation is there, and from our performance centers of excellence also has a repository of suggestion based on the degradation. It also suggests if it is a RDS resource, then what you need to do, how can you horizontally think about solving that problem. Those suggestions are there, and that's where we have reduced down that baggage of our QA engineers to manually run the test, block those slots, analyze those reports, and then have those discussions with architects, how to optimize that. All that process was been automated, and every Saturday the report comes in. Every Monday, in the mailbox of our QA engineers, that report is, they take that report, file bugs. Today that process of filing bugs is manual, but we are also thinking as the confidence grows in, even that process of filing bugs will be automated for Jira. This is how you will have to think. That is the biggest baggage, by the way, when you are CI/CD. When you are taking your things to production every sprint, if your sprint cycle is 3 weeks, 4 weeks, which means that you have to do performance engineering every sprint. How can you get to the lowest of this pyramid, where you can have a maximum coverage of your test cases at the lowest cost at one single instance? Can it be nightly built? Can if it is a mocked performance test at a unit level, you can even run that nightly. If it is a integration test at a single instance level, you can run it weekly, and you can deploy in a CI/CD manner at the end of every sprint. This pyramid is very important. This pyramid is very important to understand. See how you can follow this pyramid earlier in the stage. With this, we went through various parameters. All of this is the vision a particular leader or an architect has for their teams. He keeps on directing them to keep the cost low. All of this goes in when if your engineering team doesn't have a plan on the shop floor. Now, at this moment, I will hand it over to the true person who actually makes this vision possible. It's the engineering aspect of it, where now Devendra will help you out to go through various engineering shop floor considerations to make this successful. Over to you, Devendra.
Sure. Thank you. Thank you, Yuvraj, for providing us the valuable insights. Good morning, everyone. Building on what we have just heard from Yuvraj, I will take us a step further by focusing on the practical implementations. We will explore the 5W and 1H approach to tackle the challenges of cost optimization. And using the same approach, we will see how to improve process, identify inefficiencies that are there, and make better decisions. To make it more relatable, I will share some real-world case studies as well, showcasing how in our organization we have successfully implemented this approach to drive cost efficiency without compromising on the quality. So let's dive in. So the first question here is what? It is simple. What do we really need to create or scale? It could be your tech stack, it could be your infrastructure or any other resource that is there in your AWS environment or cloud environment. The mistake that I often see is over provisioning. That is getting way more capacity than the workload requires. Instead, we need to focus on scaling realistic based on the actual workload and scenario. So as Yuvraj mentioned earlier, like if we are starting, we do not have to go into multi-cloud or we do not have to test with 10x. If the growth expected is 2x, then it's better to test with 2x or 2.5x initially. The key is to align resources, what is truly needed. And it is also important to revisit the decisions regularly because the workloads may change, the business requirements may change, and we have to be aligned to the business requirements and the growth anticipation that is there. So what made sense, maybe if you are rapidly growing, so what made sense 6 months ago may not be relevant today. So we have to adopt and align as per the need. So I will take an example here. So if you see this one, this is a case study, what we are following over here. So there are 3 applications in 3 different clusters, A, B, and C. Now, if I have to do an end-to-end test for application A, the anticipated load for application is 100 TPS. Once A is injected with 100 TPS load, it interacts with B, and the load that goes on B is also 100 TPS. But no load is going on C because the scenarios we are testing, A and B are enough to cater those scenarios. And the way we will be scaling in this, we will scale A to 100 TPS, B to 100 TPS, and we do not have to scale cluster C in this case. So instead of provisioning resources across the board, we will scale the required infrastructure, specifically components A and B, to handle 100 TPS load. And if we consider A, B, and C are of same size and incur same cost per unit of time, and if we follow this approach, we will be able to save 33% of cost because we are not scaling C in this case. So it will only be A and B that we have scaled. We have not scaled C. But if we have not made this informed decision, we would have scaled everything and we have incurred 33% more cost in this case. So this shows like aligning resources precisely what with the expected workload can lead to the substantial cost reductions. Let's see another example. So here it's the same infrastructure, but what we are doing is we have changed the focus from application A to application B. And application B, when we are injecting the load, we are expecting 200 TPS to go on application B. And as a result, since you can see like application B is interacting with A and C both, so the 100 TPS or the scenario, suppose we are testing 2 scenarios, 100 TPS and 100 TPS on B. One scenario, B is itself able to cater everything. But for the other 100 TPS, it is distributing 50 TPS to A and 50 TPS to C to cater those scenarios for the end-to-end. Now, if we scale everything uniformly with 200 TPS, so and make an uninformed decision, so people will scale B, A, and C all to cater 200 TPS load. But when we make informed decision, we will scale the infra in targeted way, and we do not over provision any of the components. So the scaling of each part will be happening in the system will be happening on the real demand. So A is getting demand of 50 TPS, C is getting demand of 50 TPS. So we will be scaling A and C as per 50 TPS load. We will scale B as per 200 TPS load. And as a result, we will save 50% cost in this in comparison if we would have scaled everything at 200 TPS. Because if I consider this in terms of units, so suppose B consumes 200 units of resources per hour. If we have scaled everything, it will be 600 units consumed in 1 hour. But in this case, if we scale 250 and 50, it will be only 300 units that is consumed in an hour. So you can see like 50% instead of scaling everything to 200, if we scale to 600 cumulative and 300 cumulative in this case. So this is how the first question we have to answer, like scale whatever or create whatever you need. Do not scale or do not create anything beyond that. So the key takeaway from this, the question of what is to scale each component of the system independently based on the actual workload demands for that particular component to optimize the cost. Now we will switch to why and when, the other 2 Ws. We will cover both, and after that, we will see a case study. So when we talk about why, we need to understand the region before we start provisioning the resources or creating the resources. So it is important to brainstorm why we need the resources. First of all, what is the purpose? As Yuvraj has mentioned, like we have to do benchmarking, or we have to do sprint load test, or full load test, or chaos. So the purpose of test will different in different type of scenarios that we are targeting. And for all those scenarios, we have to the provisioning of the resources or the scaling of the environment that we have to do will also be different. So we have to keep that in mind. We have to also think of what value add it will bring to the business. So in the case study, we will discuss that. So apart from this purpose, value, and why we need that, we have to also ensure the production reliability. So we do not have to trade off that we want to save the cost, but we have got a hit on production reliability. So we have to ensure that we are provisioning whatever we are provisioning, or whatever we are proposing to provision in production will keep the things running smoothly while the application is live. And we have to also keep aligned with the business objectives. When we talk about this thing, we have to also identify the right timings for scaling the resources. So scale up, we have to always focus on scale up when you need it. If you do not need it, you have to scale it down. So there is no point in provisioning resources that are not being used. If you need to test some application, scale up before running the test. Once the tests are complete, you can scale down to avoid unnecessary cost. And one of the key things to focus here is automation. It will help you to scale your infrastructure up and down based on demand, and it will also ensure efficiency. It will save your time and cost, and you will also get rid of the manual intervention and the manual human error that happens if you are doing it manually. Uh, Now, this approach to scale up and scale down can be applied to production as well, not only in non-production environment, but in production as well. So when you monitor the usage pattern in production, you can scale up when the peak traffic is there, or the usage is expected, a lot of usage is expected, so you can scale up during that time. You can scale down when the traffic is and the usage is reduced, like during nightly hours or over the weekends. So this way, we are scaling at the right time, and by automating the process, we can save time and have added efficiency into it. Let's see an example. So the below architecture is an example of a multi-region application. Now, when we ask the question of why do we need a multi-region architect? So the answer is simple, that some applications have very critical availability and reliability requirements, like of 5 nines. So if there is a requirement of 5 9 uptime, this means you can have downtime of less than 6 minutes in whole year. And to be precise, it will be 5 minutes and 13 seconds. So you can only afford to be down for 5 minutes and 13 seconds, not more than that. If you have got 5 minutes and 14 seconds of downtime, you have breached the SLA of 5 nines uptime. So in this case, we have to cater the unexpected failures. To cater that, we have to support automated failover across the regions. So if something goes down in region one, the application or the user that are currently being catered by region one should automatically switch to region two, and there should not be any impact at the user experience. It is also very crucial for disaster recovery when we talk about multi-region application. So having infrastructure in another region can help you to quickly recover without any significant loss of service or data as well. So when we ask the question why, it will help us to understand the purpose, the value add. And in this case, like if you have these requirements of 5 9 0 downtime or automated failover or disaster recovery, if these are the requirements, these are the business objectives, then multi-region architecture will do a value add and it will solve the purpose. But if these are not the requirements, or if you have requirement of any, like suppose 9 8 uptime, so probably you do not need a multi-region architecture in that case, and you will be spending or burning more money if you implement this thing. Now we will see how the test harness will work for these type of application. Like if we have multi-region application, so how we will test that. So to test this, we have to deploy our application under test into multi regions. we have to scale out the application before the test to ensure everything is ready. After the test is complete, we should scale down to avoid unnecessary cost. Now, the other part of the setup is the load generators, the machines from which we will be simulating the loads, or the virtual users who are simulating or doing the actions on the application. So we will also deploy and bring our load generators up and running when it is required. So we need to deploy LGs in each of the regions to simulate traffic from corresponding regions. So suppose the region one load generator will send the traffic to the region one application. We will scale up the load generators when we need them before the test, and scale down after the test is complete to optimize cost. So in this case, as Yuvraj has mentioned, like chaos scenario is also very important to test if we are targeting 5 nines for a multi-region architect. So we have also introduced a chaos scenario in which we will bring down one of the regions to test how the system behaves. So one expectation could be that traffic should automatically gets redirected to other regions, maybe based on proximity or whatever distribution algorithm is being defined. We will verify the latency. Suppose if region one is gone down, so how the response time or the user experience will change for the region one users if they are getting served or catered from region two, because that will be the nearest proximity region, but the number of hops may increase as compared to region one. So we will check that. From the application side of view, we should see whether region two is able to scale and can still remain stable under stress if the load has been doubled, because now both region 1 and region 2 users are coming and catered by region 2. So this is one type of example. Now, considering my team is sitting in India and we are keeping this environment up and running, all the LGs up and running and application up and running for 24/7, this will incur a lot of cost, because one application cluster can incur thousands of dollars. If we have multi-region, it could be multi-$1,000. If we keep, and my whole team is sitting in India only, so their working hours will be somewhere around 6 to 8 hours during the India time zone. But the rest 16 hours that they are spending and keeping the system up and running, they will not be utilizing that. So if we reduce and follow this approach, like to scale up when we need and to scale down when we do not require that, we will shut down the environment or scale down the application, shut down our LGs, shut down the infrastructure completely. And next day morning when I come up, I have my scheduled jobs running at probably 8:30 a.m. I have scheduled them. So by 9, if I reach to office, the environment will be up and running and I'm ready to go with the tests. So if we follow this approach, we will be able to save considerably 66% of the cost based on 8-hour usage window by effectively managing scale up and scale down resources only when it is necessary, rather than running it up and keeping it up and running for 24 hours. Let's see who will be responsible for cost management and optimization part. So when we ask who, this involves and gives the responsibility of cost management and optimization to various teams and members. Clear accountability and ownership across different teams will be defined in this. If I take example of FinOps, so FinOps will play a critical role in tracking and managing cost across cloud resources, across environments, across different accounts that are there in the organization. Cloud architects, they will be responsible for designing cost-efficient cloud infrastructure. So if they are designing something which is suppose they are proposing solution 1, which can incur more cost as compared to solution 2, but solution 2 also can meet the same SLAs or the requirements. So they should design the system in such way that it should be cost efficient. Then comes performance engineers. They will focus on test execution and system runs that are efficient without overspending. So the example that I took, like bringing up the system and scaling when it is required, when they are testing, and scaling down when they do not require. So that is an example for performance engineers. DevOps will also play a key role by automating the processes, ensuring infrastructure is provisioned and scaled appropriately. In our organization, we have very thin line between performance engineers and DevOps, and there are some automations that performance engineers they are writing, and they are kind of switching into the DevOps role. So it depends on different organization to organization how the setup is there and how the responsibilities will be defined. There could be other stakeholders like project managers or your business leaders who ensure that cost management aligns with overall business goals. So this is with respect to the who. Now, together, all these teams must collaborate and ensure that cost optimization is maintained consistently. So for this, we have prepared the RASI matrix. Uh, this helps to clarify roles in cost management and optimization. So there are some tasks and activities that we have listed. And if you see in the different columns, there are the roles or the roles that each organization may have. These tasks and activities and roles may differ from organization to organization, but this can be taken as a reference to define the clear responsibility and accountability for each of the team members while designing the cost optimization process. So in this, if I talk about responsible, who are responsible for this, so these are the individuals or teams who work at implementation level and complete the task on ground. So for example, if I take identify performance bottleneck, performance engineers are responsible for that, because the performance engineers will handle the execution and they will do the root cause analysis. So they will identify the bottleneck and they will identify the root cause for that particular bottleneck. If I take example of accountable, so these are the people who owns the task and who is answerable for the success of a particular task. So like analysis of cost implications. In this one, someone from FinOps team will be accountable for this, while performance engineers will be responsible for this. So FinOps team in this case will ensure that the goals are met and that the task stays on track. So this will be the accountability of FinOps, but the responsibility of performance engineers. Now, coming to the consultant, these are the people who provide advice and insights that can influence the decisions that the person who is working on ground is working. So it can influence those decisions. So it could be your subject matter expert like DevOps team or cloud architects as well. So if I take example of performance bottleneck itself. So now the performance engineer has identified the bottleneck. They are responsible for it. Cloud architects needs to be consulted to get insights that what will be the broader impact of this bottleneck. It should not impact any cross domain or dependent application because of this bottleneck, as Yuvraj has mentioned. So if a bottleneck is coming, do we have circuit breaker in place so that it should not replicate, or it should not cascade to the downstream applications? So cloud architect should be consulted to understand what is the broader impact of the bottleneck, and that needs to be analyzed and addressed. So that is the consulting part that the cloud architect will provide. And now how to fix that bottleneck and how to resolve the issue, now the things will change because the developer will also come into play. Your performance engineer has given some suggestions, but now we have to implement circuit breaker and all those things. It should not impact the downstream system. That insights we have got from our cloud architect. So this will impact the decision making to fix that bottleneck. Now the last one is informed. These are the people who will be kept updated about the progress and outcomes. This could be other stakeholders like project managers or team leads who needs to stay informed on the task and status, and they will be aware of the business objectives so that they can also provide their insights based on that if something is not on track and those things happen. So by defining these roles, we ensure that everyone knows their responsibility and contributes effectively to achieve the common goal of cost optimization and performance engineering. Now coming to where. So where guides us, where should we focus our efforts to optimize the cost? So we can identify regions, we can identify account. So if we are starting, suppose from Oregon region or APAC region, if you talk about AWS, the prices in APAC region are higher as compared to Oregon. So some regions will have higher costs due to the factor like resource pricing are itself high as per the offerings from the cloud providers. So it is worth evaluating if we can optimize resources by moving our workloads to more cost-effective regions, if that makes sense. We should also focus on various environments like production environments are critical, but mostly what happens, the unused resources that are there, they often sit in non-production environments like performance or staging or development. So suppose if someone is creating some resource for a POC purpose or some proof of concept he is doing, and after completing that POC, he has given the report and everything, but he forgot to remove the resources. So now these orphan resources will keep on sitting and incur cost. And if you are not regularly monitoring them, or if you are not having audits, they will keep on sitting for years over there, and nobody will give a thought about that. So not only production, but optimizing the non-production environments can also save significant amount without affecting the core business. Because if you are removing something from the non-production environment, there will be no impact on the business at all, because your production is as it is. So this point should not be taken like we should not optimize the production, but we have to keep an eye on both production as well as non-production environment. Other area of focus is expensive services. So there are certain services which are priced at premium. Like if I talk about Neptune is priced slightly higher as compared to normal because it is a GraphQL, so it is priced at premium. It will incur more cost as compared to RDS or any other storage. If I am talking about caching will be more expensive as compared to the normal storage. So we have to also identify them, whether we need those services that serves our purpose or not, or we can explore the cheaper alternative that are available to reduce their usage. We can also apply the 80-20 rule to approach optimization. So often what happens, like 80% of the cost comes from 20% of the services or the resources, and identifying these can help us target the biggest areas for cost saving. And lastly, we have to need to balance between short-term and long-term approach. Short-term might be easier to implement, like shutting down unused resources. Long-term could be redesigning architectures or optimizing the query or data model, implementing automation to scale up, scale down, putting everything into the pipeline. So these can be your long-term tasks. I will take an example for this. So here, if you see, the context is a team was testing an application that involved Neptune cluster. And there are two approaches that we will see in this. The first one is vertical scaling, and the second one is with respect to the optimization. So in the initial round of test, when they tested with 2x large instance, they were using Neptune cluster with 2x large instance, and they saw that CPU utilization was somewhere around 90%, which means the expected load of the instance is almost hitting the maximum capacity. And after the first round of test, they decided to vertically scale. So from 2x, they moved to 4x. And this reduced the CPU utilization to 55%, because vertical scaling, we cannot say like if we double the resource, the utilization can come down 50%. It doesn't happen. Linear relationship is not there. So the CPU utilization went to 55%, which is under SLA of 60 to 70%, and they are good to go. There was another requirement with high availability. And to cater this, they decided to go with two 4x large instances in production. In the second approach, they tried to optimize rather than go to vertical scaling. So they improved their graph data model. They applied proper indexing. They aligned the relationship with the query pattern and used filters effectively. And after doing these changes, they were able to support the expected load, what they tested in round one. In round two, they got the resource utilizations down to 60% from the 90% after doing these optimizations. Now let's see the cost implement. Again, they also have the same requirement of high availability. So when 2x large resources in production. Now let's see the cost implication of this one. So this is a snapshot from the AWS website where you can see the costing of different instance size, and the costing is mentioned per hour. In this table, I have calculated the cost based on cost per day and cost per year. So in the first approach, if you see, if we go with 4x large instance, it will cost somewhere around 76,000 US dollar. In approach 2, when we have done the optimization, it will cost me 38,344, and our savings will be 38,000. In approach 2 itself, if we have to have a better MTTR, we can add one more instance, and still we will save 19,000 US dollars. Now, this is with respect to one Neptune cluster. You can imagine what will be the cost save if it is a multi-region, multi-cluster enterprise level application where you have maybe hundreds of Neptune clusters that are there. So you can see the impact. Now, I will leave it to you to decide which approach is good or bad. But there are other parameters that we should take into consideration before deciding this thing. So suppose if the first round of test that we have done and the time to market that we are looking is within few days. So do we have the time and enough bandwidth for optimization? Maybe no. In other scenario, if we have couple of weeks or a month to go in production, we have enough bandwidth to optimize. So should we go for vertical scaling approach in that case? No, that will not be a good decision. So this example shows you what could be a short-term approach. So if you have to go live within few days, you got okay, we are getting 90% utilization. We do not have bandwidth and time to optimize. We can vertical scale, go into production for short-term. Long-term approach will be to optimize that, test it thoroughly, and then in the next maintenance window or in the next cycle, reduce it from 4x to 2x. You can save the cost on that. So depending on the situation, you can define your short-term, long-term approach and how to optimize the cost in the production as well. Now let's talk about how. So how do we continuously optimize? We need to understand that cost optimization is not a one-time task. It requires ongoing attention and it is continuous effort. So key aspect is regular monitoring. We have to regular monitor so that we can adjust in real time, then waiting for the next billing cycle when the cost occurs. One important factor is implementing cost strategies. This might involve right pricing models, like using reserved instances or spot instances in test environment or in staging performance. You can use these spot instances when you require them. You can also leverage auto scaling in production when you use get the resources when it is necessary, release them when it is not required. Budget allocations are also essential, like setting up clear budgets for different teams and different environments to ensure how the spending is aligned with the business priorities. And you can also track how much budget or how much spending each department or project is staying within the budget. And last is the approval process. So have a clear approval process. If a new resource is getting provisioned or infrastructure is getting provisioned, there should be approval process for review. So any additional spending should be justified and aligned with the cost optimization goal. So that is the approval process. So if you follow this one, you can build a culture of continuous cost optimization. Now we will discuss like how we implemented this in our organization. I'm a big fan of Dhoni, and I believe in his philosophy that process is more important than results. So if the process is right, the results will follow. But the question here is implementing a robust process takes time and effort, and it is not an immediate fix. So if you want to put up a process, it will be a strategic investment. It will take some time to build that process. And the major part is it will take some time and effort. So now we, as a team, we gave a thought on this and we decided like, okay, we do not want to overly focus on process itself or just one side of the scale, but we want somewhere in between the process and the results. So meanwhile, if we have to establish the process, it will take some time and effort. We have to identify the team and everything. What can we do so that we can get some low-hanging fruits? We can shift towards the results. So while the process guides our actions, we should also be mindful about the end results that we are having. So we aim somewhere to be in between of the scale, optimizing both the journey of the process and the destination that is the results. So now we will see the implementation of process and check some of the quick wins for the low-hanging fruits for immediate cost savings while you are building the process and spending time on that. So to guide our journey with respect to the process in cost optimization and performance improvement, we introduced the performance engineering maturity model. This framework helps us to gauge where we stand as of now, where each microservice or each product stands. We evaluate that, and based on that, we categorize them on what level they are there. So by evaluating this or the service on the maturity scale, it helps us to define the areas of improvement, and it also helps us to set the goals where we are lagging and where we have to focus. So there are different levels in this. Like if I talk about initial, The processes are ad hoc in this. There are no standard process, no standard tool. Team may tackle issues as they arise without any predefined strategy. Focus on testing, performance engineering, and cost optimization is minimal. Very less effort is given to that. The approach is reactive. Uh, Example will be like you have got issue in production and then you are testing it in your test environment, fixing it, and then going into production again to fix that. So that is a reactive approach. The second one is managed. So here you have clearly defined your processes. Processes are repeatable. They are documented and teams started following them. The basic coverage is there, like basic critical scenarios for performance, like login or authentication, they are in place, but still there are many gaps in the comprehensive coverage that is there. Some automation is there, like instead of manually scaling the infrastructure, you have created some Jenkins job, but there is still room for improvement in terms of complete scaling or automated benchmarking runs or some those things. Third one is defined. So in this one, we have improved the practices. We have started following the well-established industry standard practices for performance testing, cost optimization. The coverage is significant. Like apart from the basic critical scenarios, we have added some more scenarios for performance testing and cost optimization. Now we have built some dashboards to see what resources are incurring cost in Cost Explorer or in our billing dashboard. And we have increased our coverage from non-production environments to production as well. So we are looking into both production and non-production environments. We have tools that are integrated, like we are using Glowroot to identify or drill down what is happening at the application server level, or maybe using Gatling throughout all the for all the projects in domain, so that we have a sync in what tool we are using. Then we have the next level that is measured. So in this one, we are actually doing data-driven decisions. So we, as Yuvraj has mentioned earlier, we are observing the usage pattern from production, aligned our test suite to test ahead of what is the usage pattern in the production. Like if in production, suppose you are getting 100 TPS load, so while testing or certifying, you are certifying it at 150 TPS load. So if something goes wrong or you get a spike in production, you will be able to manage that. So every decision is backed by evidence and leads to more accurate and effective strategies. Now, the automation has been scaled up in this. So from the resource scaling to performance testing, everything is automated. Automation is integrated part of every aspect. So if a new feature is coming off or a new service is coming, you are focusing not only benchmark that or test that, but you are also focusing on benchmarking that particular service using automated way and not doing that manually. And you have reduced human intervention in that case. Proactive bottleneck resolution. So as I mentioned, like we are ahead with what is there in production. So we are testing proactive. We are fixing the issues proactively. So if some issues would have come at 120 TPS and we are testing with 150, that issue we have caught at 150 TPS, and in production we will not get that issue. So catching and fixing of the issues in load cycle is happening before they become any problem in the production. Now, level 5 is the zenith of this. It's the peak performance and cost efficiency we have achieved, where everything is automated. Now we are focusing on continuous improvement and predictive strategies at the forefront. So we can implement the extrapolation model. Like if we have 10 million agents we are expecting 10 million. We do not have to test with 10 million. We are aware where are the bottlenecks in our system, where we have to do horizontal scaling or vertical scaling. We are aware of that. And we have designed the extrapolation model. Based on that, we are predicting when we will getting the issues. We are continuously monitoring the production. We have put alarms and everything. We have put alarms so that we can get notifications if everything goes wrong in production. And teams in this case, they will always look for improving the process and enhance efficiency to reduce the cost. Predictive analysis, as I mentioned, like this will allow to anticipate the needs before they arise, and we will make proactive decisions. Like if I know that Black Friday is coming or Cyber Monday is coming, so I will scale up or I will provision my system before that, because I know what is the requirement that is coming, and after that I will be scaling down as per the requirement. The systems will be cost efficient. Every system and process is fine tuned for the maximum cost efficiency. So this is one thing that we have to target in this one. Now, when you reach level 5, the the full integration and optimization has become the DNA, become the culture, and predicting achieving the best possible outcome in terms of both cost and performance should be the goal for any project or any service that is at optimized level. Now the question is, we have defined the levels, but on what key parameters or key dimensions which are used to define this, how we are evaluating. So to ensure this thing, we have defined some of the key dimensions over here. Like the first one is process integration. So when we talk about integrating process, this one is like integrating process into the larger organizational workflow. So if I take example like in the SDLC cycle itself, while designing in the designing phase itself, the team needs to derive and get clarity of how much cost a particular solution will incur. So if team is discussing on a particular solution, there should be also discussion or meeting happening. There should be evaluation happening, like how much cost this particular solution will incur. So normally this doesn't happen in various different organizations, but in our organization we have implemented that. Like if a solution is being proposed, what will be the cost to be incurred? How much cost we will be spending in testing for that? So that needs to be integrated. If that refers to the process integration. Then test coverage. Test coverage is with respect to the critical component level test and end-to-end test. So we have to enhance the coverage so that we do not miss anything critical or crucial, that and how the system performs under various conditions. So example of chaos is one critical thing that test the systems, helps us to test the system under extreme condition for the system reliability. Automation is also the heart of cost optimization. So for auto scaling resources or automating performance tests and cost reporting as well, to eliminate the inefficiencies, running scheduled tests during nightly hours or save manual effort, automation is one of the key dimensions. So this not only saves the time, but also ensures consistency and scalability across the project. So if my performance engineer, if I have one performance engineer who is working on 3 projects and he is doing it manually, if I get 5 projects, he will not be able to sustain. So until unless he automates everything for those first 3 projects he was working on, he can take 2 more projects or 2 more applications to test. But if he is not doing automation, he will not be able to scale as per the new requirements that are coming. Then the fourth one is scalability and optimization. So scalability ensures that we efficiently handle increased loads without over provisioning resources, and optimization helps us to reduce the waste and ensure that resources are used very effectively. The fifth one is cost awareness. So ensuring that all team members are cost conscious is essential for sustaining optimization. And by making cost awareness a core principle in decision making, we ensure that team actively seek the most cost efficient solution. So one more point to realize here is the performance engineering is an ongoing journey. So if you reach a higher level of maturity, it is important to understand the process is dynamic. And if today you are at level 4, it may be possible due to the change of process or tools or strategies, you can move backward to level 3 or level 2. So this should not be considered as a setback, but a natural part of continuous improvement process. Now, the previous slide was a bit theoretical, but here we have made like how we will be quantifying it. So we have given different weightage to each of the key dimensions over here. And we can see like if we have given weightage of 20% to process integration, and if in a domain there are 10 projects where 5 projects have done proper process integration, so the score for that domain will be 10. And we will be getting a cumulative score based on all the dimensions, the weightage that has been defined. And we can we can give the scale to that particular domain on what level they are standing over there. So if some project is getting 10% in process integration, 20 in test coverage, 10 in automation, and suppose 5 in scalability, cost awareness, and that cumulative score is 55, so they will stand at level 3. If someone is standing at 15 cumulative score, they will be standing at level 1. And through the example calculation, you can see like which areas we have to improve. So this will help us to quantify the details. These are the benefits that we will achieve when we follow this 5W and 1H approach. So consistency, accountability, control over the cost, monitoring and reviews, quality, continuous improvement, and culture. These are the benefits that we will get from this approach. Uh, Now we have also discussed, like, we wanted to be here, and there are few slides that I have included for quick wins. I will go through them rapidly because we are already out of time. So these are some of the steps to optimize the cost. So you can see AWS. You can use AWS cost management tools that are there, like AWS Cost Explorer. This will give you help us to visualize, understand, and manage our spending budgets. You can set custom budgets with respect to accounts to stay within the planned expenditure limits. Billing dashboard, it will give you an overview of accounts spending and usage. So you can see that at the end of the month, how much expenditure you have done for each of the service or each of the tags. If you have put cost allocation tag for each of the department and specific project, so you can see those details in billing dashboard as well. Then usage and identify trends, like CloudWatch matrices, you can use to see the usage and what are the trends that are going on. You can implement your scaling pattern or auto scaling pattern according to that. Uh, you have to conduct regular cost reviews, like monthly cost audits. Team will miss it and they will uh, do the audit, like what is the budget. Suppose they have a budget of 20,000 US dollars for the month and they have spent 15,000. Okay, they have saved 5,000, but if the expenditure has increased to 18,000, so what was the reason that 3,000 has been spent extra? So those things you have to do regularly. Then the last one is educate. This is also very important one, to inculcate the culture of cost awareness in the organization. So you can have brown bag sessions or regular knowledge sharing sessions within the team. What are the best practices for cost optimization or well architected framework? Uh, so I have taken example of AWS, but this can be taken as reference for other cloud providers as well. They will have the similar kind of offerings to measure the cost and billing. And these are some other areas that we can also look for potential cost leakage for those who are working at the implementation level, and ensure that they are aware of where inefficiencies or unnecessary spending may occur. This list can help with this list can help them, which includes like idle resources, over provision resources, unused capacity, data transfer cost, storage inefficiencies, elastic load balancer, orphan resources. And this goes on, like misconfigured auto scaling, monitoring and alerts, licenses and subscriptions that are there, and development and test environments, like the non-production environment that we have discussed, custom pricing options that are there for EKS as well as ECR images. So you can look for spendings over these lists to control any cost leakage that is there, that is happening. Yeah, so that's it from my side. Over to you, Yuvraj.
Yeah, thanks, Devendra, for going through all of the shop floor considerations. It's not just about realization, but how can I quantify my present state is very important. And ultimately, what one has to remember is frugality, whatever you want to call that, drives innovation. So don't have a loose hand on costs. As an organization, for last 5 years, our performance engineering costs are stable. We have fixed that budget. We haven't increased that budget even if our customers have increased. So don't keep a loose hand on it. Then only people will innovate and automate things. So that is how I will like to summarize overall. And I will hand it over to Monish. Yeah.
Thanks a lot, Yuvraj and Devendra, for this
Monish, you
insightful
are on
session.
mute, I think.
Uh, can you hear me?
Okay. Sorry.
Yes. Okay.
I am able to hear
Thanks a
you.
lot. Yes. Thanks a lot, Yuvraj and Devendra, for this insightful session. We are definitely have a lot of questions and encourage our audience to keep dropping questions, considering the time constraint. Let's keep few questions for now and go over it. Question for you, Yuvraj. Can you give a practical example to when to choose vertical or horizontal scaling?
Definitely. So when you actually are doing bulk operations, right, inside a microservice, usually let's assume that you are processing thousand records. When that number needs to be increased, and you are doing it that using a strongly consistent architecture rather than an eventual consistent architecture, you will have to vertically scale. So your actual architectural choice is a problem there. So when you do bulk operations, go for eventual consistency, and so that you can effectively use the resources. And vertically scaling, as far as possible, we should avoid uh, to have build architectures which need vertical scaling. In the initial phase of incubation of new ideas, when you have chosen monolith, when you don't want to build very too many artifacts to manage, too many CI/CD pipelines to manage, during that time, vertical scaling is okay. But gradually, when your business grows, when your uptime requirement increases, go for a horizontally scalable architecture. That's one example. The other example can be your databases. Your writers have to vertically scale usually, and your readers are horizontally scalable. So while you are writing, when you are writing in a strongly consistent manner, your need for vertical scaling will be higher. If you are doing it in a eventually consistent manner and slicing is happening, your need for writers to be smaller. You will see that your writer size will be small. So those architectural choices matter.
Yes. Uh, Next question. During the initial lean phase of SaaS, what's the important suggestion to keep in mind?
The important suggestion to keep in mind in this case is for all the three personas, by the way. For when it comes to business, be realistic. Don't come up with the requirements, or don't enforce the requirements which are 10x. We envision to grow 10x in next 5 years, but that need not be tested. Not every application requires a uptime of 5 nines, because when we say 5 nines, the investment into architecture and infrastructure are higher in those cases. That's from the product point of view. When it comes to architects, right? Keep it realistic. Not every it's really funny, but architects and developers have a habit to hallucinate on many requirements as such. They consider some virtual requirements from the NFR point of view, non-functional requirements point of view, and we try and do the best. You have to have a sweet balance. If an architect has a team in the earlier incubation phase of 8 people, can you go with a microservice architecture with 10 different components? No, you managing that CI/CD pipeline and deployment itself will be a pain. So architects also have to be realistic. In this initial phases, what we should go with is very simple things. We have a platform service, we have a common layer service, and we have a application level service, which has business logic under those. So go with a very lean architecture there. So that you will have very few pipelines to deploy and manage. You can more concentrate upon functionality in the earlier phases rather than the NFR part of it.
Thank you for the answers, Yuvraj. Considering the time, let's end it here. And uh, for those who are wondering if you'll get a recording of the session, the recording will be available soon in YouTube in our Zinos channel. And you can drop a note to Insights at Zeno to keep you posted on the same. And thank you, Yuvraj and Devendra, once again for graciously sharing your insights and expertise. Uh, Session today not only addressed the questions at hand, but also sparks some thoughts and discussion for sure. We hope to have you in our future tech webinars as well. And a special thank you goes to each and every one of you for your presence today. Thank you, and looking forward to seeing you at future Zeno events. Take care, stay safe, and have a great weekend.
Thank
Ahead.
you. Thank you all.
Thank you. Thank you all.
Thank
Bye.
you.